We see airplane windows every time we fly, perfectly rounded, calm, almost friendly, but that shape exists because people once died when it wasn't. And understanding why airplane windows are round reveals a design mistake so severe. It permanently changed how machines are built and how humans survive inside them. Most people assume airplane windows are round for comfort, or aesthetics, or simply because they match the curve of the aircraft. It feels intuitive. Round shapes look modern, clean, engineered. But that explanation collapses the moment you look at early airplanes, because they didn't have round windows, they had square ones, and for a long time, nobody thought that mattered. In the early days of commercial aviation, aircraft were simple compared to today. Flights were short, planes flew lower in the atmosphere, cabins weren't pressurized the way modern planes are. Passengers wore coats, oxygen levels were barely considered, windows were small and flat, cut directly into metal panels. Square shapes made sense. They were easy to manufacture, easy to reinforce, and easy to replace. Engineers cared about engines, wings, fuel, and lift. Windows were an afterthought, and at first, nothing went wrong. Then aviation evolved. As engines improved, planes began flying higher. Higher altitude meant thinner air. Thinner air meant passengers struggled to breathe. Fatigue set in. Flights became uncomfortable and dangerous, so engineers introduced pressurized cabins. This changed everything. Instead of matching the outside air pressure, the inside of the plane was sealed and artificially pressurized. Suddenly, flying high was safe, comfortable, efficient, but this single innovation quietly transformed the airplane into something else entirely. It became a pressure vessel. Every time a plane climbed, the air inside pushed outward on the fuselage. The metal skin stretched, not visibly, not dramatically, but measurably. Every time the plane descended, the pressure reduced and the metal relaxed again. This stretching and relaxing happened on every flight, over and over, thousands of times across an aircraft's lifetime. And this is where the danger began. Metal doesn't fail the way people expect. It doesn't snap instantly when it's overloaded once. It weakens gradually under repeated stress. This process is called metal fatigue. Each pressurization cycle introduced tiny stresses into the aircraft's body on their own. These stresses were harmless, but repeated thousands of times, they began to leave a mark. Microscopic cracks formed, not everywhere, only in specific places, places where stress concentrated instead of spreading out. And the worst places were sharp corners. At the corners of square windows, stress had nowhere to go. Instead of flowing smoothly through the metal, force piled up. Each flight pushed slightly harder on the same tiny points. The cracks grew slowly, invisibly, and detected by routine inspections that weren't designed to look for something this subtle, until one day, the metal could no longer hold. Mid-flight, parts of the aircraft suddenly tore open. Pressure inside the cabin escaped violently. Entire sections of fuselage failed in seconds. These weren't pilot errors. They weren't engine failures. They weren't storms or sabotage. They were design failures. Investigators studied the wreckage and found the same pattern again and again, cracks radiating outward from window corners. Tiny flaws that had grown quietly with every flight. The conclusion was devastating. The planes weren't failing because the metal was weak. They were failing because the shape was wrong. This forced engineers to confront a hard truth about design. Strength isn't just about material, it's about geometry. So they asked a simple but profound question. What happens if you remove the corners? They tested round openings, circular cutouts, smooth curves. The results were immediate and dramatic. In a circular window, stress doesn't concentrate. It flows evenly around the edge. No single point carries more force than the rest. There's no starting point for cracks. Pressure distributes itself naturally. The shape itself becomes part of the structure. The solution wasn't fully circular windows, because airplanes still needed usable space. Instead, engineers designed rounded rectangles, windows with smooth curves and no sharp angles. Every corner was softened, every stress point was reduced. This one change transformed aviation. Safety. Metal fatigue dropped dramatically. Pressurized flight became reliable. Aircraft lifespans increased. Long-distance travel became routine. The industry recovered. But the lesson didn't stay in aviation. Once engineers understood how dangerous corners could be under pressure, they began seeing the same principle everywhere. Submarines adopted circular hatches, not because they looked better, but because pressure underwater is relentless and unforgiving. Any weak point becomes catastrophic. Spacecraft windows were made round for the same reason. In space, the pressure difference is absolute. One failure means instant loss. pipelines, tanks, reactors. Even simple containers began avoiding sharp internal angles. Anywhere pressure exists, corners disappear. Even outside high-pressure systems, the lesson spread. Modern car designs avoid sharp internal edges and structural components. Buildings use rounded transitions where forces change direction. Consumer products adopt curved edges not just for comfort, but durability. Even smartphones reflect this thinking. Rounded corners distribute impact forces better when dropped. Cracks are less likely to originate from sharp edges. What looks like a design trend is often a structural memory. Design remembers failure, and that's why airplane windows are still round today. Not because it's tradition, not because it's aesthetic preference, but because engineers learned painfully that repetition is more dangerous than force. A plane doesn't fail because of one flight. It fails because of 10,000 nearly identical ones. Design that survives repetition is good design, and the airplane window became a quiet symbol of that truth. Every time you sit by one, the shape beside you represents lessons learned through loss, through investigation, through redesign. It's a reminder that the most dangerous flaws are often invisible. They hide in assumptions, in things we stop questioning, in shapes we think are harmless. Once you understand why airplane windows are round, you start noticing the same logic everywhere. Corners vanish wherever pressure exists. And the next time you look out that window at 35,000 feet, you're not just looking at the sky. You're looking at a shape chosen because the wrong one once tore the world apart.